First of all, Yannik, thank you for making it all the way out here.
Thank you a lot. Yeah, very nice venue actually.
Can be a bit searching where to go, but eventually we'll end up all here. So, thank you all for joining us today here. Yannik, perhaps I'd like to kind of like to ask you to give a short introduction about who is the man sitting here. But more importantly, what have you been doing with Arcium? This is not a shilling panel. This is just more I'm interested in what you guys do with MPC and what it means for the industry, and what are the trends as a whole with that, with regards to the topic of today. So.
Yeah, sure. So at Arcium, we're building a decentralized confidential computing network with secure multi-party computation. So the way you can think of Arcium is not as a blockchain network, but rather a dedicated, purely computational network that allows for confidential computations to be executed on existing blockchain networks. Yeah, the way I like to think of it is really Arcium being its dedicated encrypted supercomputer, and then existing blockchain networks being I/O devices to that computer. And with this cognitive model, it also makes sense to then have off-chain sources run confidential computations without actually having to care about blockchain applications as a whole. And one of the connections where blockchain really comes into play with Arcium is with a censorship resistance mechanism that we've designed. So with Arcium, it's possible to run any kind of confidential computation, arbitrary confidential computations over encrypted data without having to expose that data or share that data. And yeah, by combining blockchains with MPC and staking and slashing mechanisms, it becomes possible to have the lowest possible trust assumptions with high efficiency and censorship resistance.
And could you give for the audience perhaps an insight into what kind of data sets would be interesting? What kind of verticals would be touched by this? How would this have an impact?
Sure. So I think there's different kinds of applications being built on top of Arcium. The most straightforward kinds of applications really are on-chain applications. So on an existing public ledger, someone wants to build a confidential order book, for example, wants to build some confidentiality into their smart contracts. And with our architecture, they can do that. So we've designed a custom compiler that allows to currently compile Rust into a format that our network can cryptographically understand. So you have your application and you define confidential functions and encrypted state that should be processed in a confidential way by Arcium. And the way it works really is that on-chain, on whatever network you want to have this confidentiality, you have an on-chain mempool where this smart contract then schedules a computation, the network picks that up and settles the publicly auditable result back once execution has finished.
So blockchains make for an easily identifiable case. But I'm wondering, given the fact that you're basically providing off-the-shelf MPC, what sectors, let's say non-Web3, how would this impact in terms of tangible use cases which increase the use case of privacy in this case?
Yeah, that's actually a great question, because funnily enough, one week ago on last Monday, we announced our acquisition of our largest Web2 competitor, who've been around for 8 years building confidential computing for traditional sectors, and more precisely confidential machine learning and confidential AI, also using secure multi-party computation. They've done some of the most foundational MPC research, and so they're now part of Arcium, and their technology becomes part of Arcium. So over the last 2.5 years, we've been developing our own MPC protocol and are now combining that with their MPC protocol. We haven't really focused on any AI-related tasks. They have done that tremendously over the last few years, and we can combine the trust models and security models of those two protocols and bring that into Arcium. So I think confidential computing really is one of the big sectors actually that can bring adoption of blockchain systems without whoever uses confidential computing having to care about blockchain systems. I think the use cases that Dave tackled are good examples of that, and MPC really natively plays nicely with distributed systems, having different peers not be controlled by one single party, I guess. So they've done a lot of healthcare, actually also defense, intelligence, governmental stuff, and TradFi as well.
So I see the BTP case here. I see the complementary portion of your acquisition. How does all that translate to cypherpunk values?
So I think one of the big cypherpunk value that we've introduced is a new kind of censorship resistance mechanism, because with MPC there's basically different kinds of trust models you can operate in. Honest majority, and in our case dishonest majority, so the smallest possible trust assumption. You don't have to trust that some percentage of nodes in a multi-party computation is honest. In our case, you only have to trust that there's one single honest participant out of a set of arbitrarily many participants. So that's the trust assumption that right from the get-go we said we want to operate in, the lowest possible trust assumption, so that anyone could become a participant and have relative trust of 0, because they know they're not maliciously collaborating with all of the other participants, right? So that's the trust model that from the get-go we wanted to operate in order to protect privacy as much as possible. The problem you face when building dishonest majority protocols, however, from a practical standpoint, has always been sort of this high risk of DDoS attacks, because while you only have to trust that there's one arbitrary honest participant that isn't sharing secrets with all of the others, one bad participant that wants the computation to fail can make the computation fail, because those legacy protocols basically didn't allow to pinpoint any cryptographic misbehavior by such a malicious party. So we've built a protocol that allows to identify that, where we can cryptographically identify a misbehaving party that actively causes the computation to fail, because it's something that we don't want. We want those confidential computations to be confidential and to be executed when they should be executed. And we can combine that with game theoretical measures, staking and slashing on those existing blockchain networks, which form the sources and then callback layers for those confidential computations. And so if those computations fail, someone gets punished who caused that computation to fail. So basically adding accountability and enforcing confidential execution.
Now, I'm interested, with Arcium, you're obviously doing well, given the acquisition as well, and the cases you mentioned as examples. The concept of MPC has been around for, help me out here, is it since the initial research, 15 years now, conceptually?
I think since the 80s, something like that. Yeah. So okay. Similar to zero knowledge proofs, they had this emergence starting in the 80s. Yeah.
Okay. Yeah. No, because I think was it FHE was in 2009.
Yeah, exactly.
Published,
yeah,
and that's yeah. Okay. So if you look at the impact, especially what MPC could have on the, like I said, I see the business case here.
Yeah.
How would you see this impacting end users and their sovereignty?
I think MPC actually has the biggest impact out of all privacy-enhancing technologies that we've seen. Zero knowledge proofs and FHE as the other two cryptographic protocols. I feel like MPC will be the most impactful because it allows for more powerful interactions. I feel like at least...
Why? Please make it tangible.
Yeah, so at least I personally have been disillusioned by CK, and in the past we've built a lot of privacy technology with CK at Arcium, but sort of the kind of interactions you can have are limited. For example, operating over a shared state, encrypted shared state, right? Zero knowledge proofs are always, I have some secret and I generate a proof about that secret and send it somewhere. With MPC, that's not required. If we have this minimum possible zero trust system, be it with MPC or FHE, right? And we can just tell some ledger to run confidential computations over some encrypted state. We don't need the end user to generate zero knowledge proofs, to manage that, to do key exchanges with million different users. So it has a lot of scalability implications and implications in the kind of applications we can build. You can basically build a server application, right? You can have some server. I don't know, if we were to live in an ideal world, we could have some trusted server that could just keep all secrets and run those computations, right? And with MPC and FHE, it's possible to actually do that. To have such a server where there's no one who can see what's happening, we can force that server to actually execute, and there's no risk of data leakage. So I think that's why these kind of technologies are so powerful. Now, personally comparing MPC with FHE, why I feel like MPC is the most powerful, both are using homomorphic encryption. We are using homomorphic encryption with MPC as well. Just not the full set of homomorphic operations, only a subset. And for other operations, we're making use of so-called pre-processing, which just makes it 10,000 times faster.
So, given the impact you mentioned of scalability, the fact that you, as a user, you don't have to run the full compute as yourself, would this could I translate this to that, let's say, privacy measures would become cheaper for the end user in general? Is that something you see happening? Because as of now, the trend is to maintain privacy as an end user. It's becoming more and more expensive. Just not the stack, but also the opportunity cost, etc., to actually protect yourself.
Yeah, I think it's that for one, and then it's also composability. It's not requiring wallets or applications to actually do this kind of complex cryptography, right? It's just communicating with a smart contract, and that smart contract then, in our case, communicates with our network, right? Also through a smart contract. So there's no requirement to generate those heavy cryptographic proofs on the client side. And I think the bigger issue, really, if you look at Zcash and other projects, really is less about actually generating proofs and rather just indexing a lot of encrypted state and performing cryptographic permutations on that state to find some nodes. So all of that goes away if you're using MPC and operate over encrypted shared state. So I think that's why it just enables to do a lot more important applications. Also, I feel like with the advent of AI, there's just this important field where we require privacy protection, and the only technology that's not TEEs that I've seen really is MPC that can help with confidential training and inference in an efficient enough way.
Could you describe, in this case, given the acquisition as well, with the eye looking at the themes of today as well, how would these AI data markets look like if they would be running through, not even specifically Arcium, but given a MPC world?
Yeah, so I think what we will be able to facilitate in the ideal world would be end-to-end encrypted AI. It would really be having highly sensitive data, be fully encrypted, and then using something like Arcium for collaborative training over that encrypted data. So anyone can have sort of Apple intelligence on their phone without requiring to trust Apple. Instead, you can aggregate the data and have it stored in an encrypted way, and then have a collaborative training function be evaluated over all of that distributed encrypted data, and then have the output of that training process be an encrypted model. And that's less important, I think, for privacy, and more important for the monetization, actually, if you want to have this closed loop of people willing to provide high quality data. Because once you have encrypted weights, you can have some smart contract structure in place where people can then run encrypted inference into those models and pay the original data providers who gathered that data used for the training. So I think that will then create a sort of end-to-end encrypted AI which can be extremely powerful. I don't know, in some long-term vision, having AGI, for example, if all of the most valuable data is encrypted, you will require those encrypted training processes to actually train those valuable models.
Yeah. Well, in general, even before that, you need the compliance requirements of having a insight into your data set to know, for instance, for copyright issues or another requirement that you, and also with GDPR, your set needs to be private. Also, by the way, if the audience, if you have any questions, feel free to jump in, of course. Happy to put the fire on the guest here. I'm wondering, you mentioned in terms of components, so we have ZK, you mentioned FHE, and now with MPC you're providing a trusted setup for compute. What are you missing in this space? What could we do better, or what are we missing?
Excellent question. I feel like we are actually doing pretty well. I think we just need to build a lot more. I mean, now with the acquisition, we have an amazing team at Arcium, but still, it always takes surprisingly long to ship things. Even once you've done all of the research and written the papers, implementation takes surprisingly long. Yeah, I feel like I think scalability is still a big concern for all technologies. So I think all technologies will greatly benefit from increased hardware acceleration work. I think that's something that we will need. I think in general we've seen the trend also with other teams that they've realized that yeah, it's really not just about proving individual operations locally, but rather confidential computations, right? Global computations to be executed in an encrypted way. So I think I think there's a trend towards this, which I'm welcoming because I feel like that's required for getting more adoption.
So you mean, like you said, up the supply chain as well, given the recent nuclear investments for our different data centers to just increase the output, basically. Is that what you're aiming at? As in, we need for the advancements and in terms of scalability, we need more input at the moment?
Yeah, I think more input will help. Yeah.
Okay. What's holding you back? No, honest question.
I mean,
like I asked, what are you missing? As in, what's missing in the space
so
in terms of developments, but also what's holding you back in terms of if you look at what can you not do, even though you're building an engine basically for secure computing.
Yeah, I feel like what's holding us back. Currently, the speed of light is holding us back a bit. So I feel like communication is still just a big constraint for MPC in general. MPC is the fastest technology, but still communication overhead, be it for pre-processing or online communication operations, is a concern. Yeah, we're doing a lot of research on that front as well. I think yeah, what's holding us back is that it's not 1,000 people working on those problems, but I mean we are 20 people right now, which is a decently sized team, I think. But yeah, I think it's just about having more people work on this in general, having more research, having more engineering in the entire ecosystem. Yeah.
And today you're here at the Ethereum Cypherpunk Congress. As you provide an agnostic service, regardless of type of vertical or chain, even I would say, what's your relationship with Ethereum?
So our relationship with Ethereum, I feel like, is that I mean, the first network that we're supporting actually is going to be Solana. So it might be a difficult relationship.
Heard it here first, people.
yeah, we originated as a team from the Solana ecosystem. Actually, we were bringing privacy to Solana. Back in the day, we were called Elusive before we rebranded to Arcium, and we were doing on-chain privacy. So yeah, I feel like with this evolution to Arcium and building generalized confidential computing, we just want to bring this kind of confidential computing power to any network. I feel like Ethereum is incredibly important on that front. Secondly, I think the relationship to Ethereum is that it sort of also serves as an inspiration, because I would say in this world, which is high throughput chains like Solana or different L2s on Ethereum, I feel like yeah, what they've been lacking to a certain degree is also this research and seniority in cryptographic research. So that's what we are bringing to different ecosystems. And I feel like, yeah, the work that has been done on the Ethereum layer by cypherpunks, by different teams, also by folks from the Zcash ecosystem, right, serves as sort of an inspiration, I feel like, to how to go about things and what values to care about. Yeah.
And how does as you mentioned, you're focusing on Solana first. The current roadmap, including its scaling through L2s for every Ethereum, how does it affect you guys? As in, will your focus be more on them as the potential client networks, or how would you see that?
So
how could you aid to the evolution of Ethereum? Yes.
So the way I think about it really is that down the line we want to support any kind of network. I think it's just incredibly important because yeah, I mean what drives us is to make confidential computing as fast as possible, as cheap as possible, and keep the trustlessness and censorship resistance at the same time. So do everything at once, I guess. But I feel like that's something that any network requires, and so I feel like. Yeah, for us it's just a question of logical expansion to different networks over time.
And in terms of, you mentioned you have a team right now of 20, yeah. To advance research in NPC and implementation, do you also collaborate on hackathons and provide bounties, etc., to further research on this? Or
yeah, so
asking also for our audience,
yeah,
of course.
Yeah. So basically, this research is in-house. Most of the research that we are doing. So we have quite a few of PhDs and professors in our team who've been doing a lot of MPC and homomorphic encryption research over the years, and we are I would say the kind of research that we are doing and looking for is I would call it more of a practical kind of research. It's really looking for solutions, for efficient practical solutions for different problems that we encounter while we are building out Arcium. Yeah.
We have time left for one audience question. I'm looking at some faces here. Okay, and if not, then I'll have one. Like I said, we're here today at the Cypherpunk Congress. There's going to be a lot of parties today walking around and also talking on stage. What would you like to see today? What's your expectation, or that of Arcium or of the team?
My expectation is spreading the word of MPC. That's what I like to do. I feel like MPC is still something that people mostly associate with key management, for example, and just spreading awareness of the power of this kind of technology that allows for arbitrary confidential execution, and I feel like should be used in a lot more places.
Thank you so much, Yannik, for today.
Thanks for having me.
Let's give our guest an applause, please.